For today's lesson, our focus standard comes from Grade 8 Functions, Standard B, Use Functions to Model Relationships Between Quantities. Our topic for today's lesson comes from Applying Functions, Finding the Rule of Disorganized Data. Our essential question for this lesson is, how do you find the rule when the table is not in order? Please take a moment, pausing the video if you need to set up your header. Be sure to include today's date, set up your question column and your note column, and resume the video when you're ready to begin. So today we're going to take a look at some ways of dealing with messy data when we're being asked to find the rule or other information about them. So here are my 4 tips. Always be sure to reorder the data by the x values. So secondly, identify the rate of change and the starting values only after the data is reordered. So you always want to do this first, and then you can start to look for rate of change and starting values. However, you're going to want to be aware of gaps in the data and fill them in using your patterning skills. And always double check your work. So once you think it's complete, double check to make sure that the rate of change that you identified and the starting value work for the pattern, and double check that your numbers are correct. So using these 4 tips, I'd like to go ahead and dive into today's examples. Here's our first example. We're being asked to find the missing values and what the rule is for this table. So notice there's a couple of gaps in the y values, and our x values are all out of order. So what we're going to want to do is set up another x and y table and start to reorder this data, putting them in order by these x values. Of course, we got to make sure that we keep our x and y pairs in order together too as well. So I've gone ahead and done that for our first one. The lowest x value I could find was -4, and then 4, 12, 20, and 36. Then I made sure to keep -4's y value as 11, so -4 and 11. 12 went with the y value of 23, 12, 23, and 20, 29. So that is a good time to make sure that we double check that when we make our new table and we reorder the data, that we still keep the x and y values together. So now, in order to find our missing values, we need to start to find that change in y and that change in x to start to find the rate of change. So go ahead, pausing the video here, see if you can start to find what the change in x and what the change in y is. And then resume the video to check your work with mine. So as you can see, I've gone ahead and I found that from -4 to 4 was a positive 8, from 4 to 12 was adding 8, from 12 to 20 was adding 8, but from 20 to 36, that was adding 16. So remember what I said here, beware of gaps in the data. So when we start to see that it doesn't follow a regular pattern, or that it is following a regular pattern and then suddenly it stops, then there might be a gap, and so we're going to have to use our patterning skills to adapt. That was for our x values. For our y values, we know it skips a value because we weren't given the y value for 4, but from 11 to 23 is 12, and then from 23 to 29 is 6. So I need to use my patterning skills to say, hey, is there a constant rate of change happening here, and are there maybe some gaps I need to be aware of? And I would say that right here, there must be a gap where they didn't give me an x value from 20 to 36, because 16 is twice as much as 8. So I'm going to move 36 over one place and decide what would I need to do if I wanted to keep this pattern of +8. Well, from 20, 8 more would be 28. So it looks like if I put 28 in here, I can stay with the pattern of adding 8, and then from 28 plus 8 would put me at 36. So they had skipped over 28. So that was a gap in the data. And now let's take a look at our y values. From 23 to 29 is plus 6, and from 11 to 23 is plus 12, so it seems like here was just another gap, where if I just add 6 to 11, I can keep the pattern of adding 6 for y and then complete the rest of the table. So go ahead and do that while I try that on mine, and we'll check back to see how our work compares. So using this, it looks like the pattern for the y, if I go add 6 would take me to 17, and that fits with the pattern because 17 plus 6 would land me at 23. We already know from 23 to 29 is 6, and if I add 6 to that, I get 35, plus 6 lands me at 41. So it looks like, in double checking, that we have correctly identified the change in x and the change in y. And we would be ready to start writing our equation. So let's go ahead and do that. So we identified the change in y, which helps us with our slope. Having this change in y and change in x gives us our rate of change, with the change in y being a positive 6, and the change in x being 8. Then we also we're going to need to do some more work with that before we can write our equation, but we also need to find the b value. And remember, the b value comes from when x is 0, but on this table we don't have a value for when x is 0. So what we're going to have to do is break apart this pattern even more. And so we need to figure out where is 0 from 4 and negative 4. And it looks like it would be right in the middle, because if I go back 4, I'd get from 4, I would end up as 0, and back 4 more would take me to negative 4. So I'm going to insert a column in here. So we took this pattern of adding 8 for the x and said, well, we need to find the step in between. So half of 8 is 4, and it turns out that 0, which is what we need for our starting value, our b value, is backtracking 4 would take me to 0, and backtracking 4 would take me to negative 4. So we just subdivided this pattern. Which means if we subdivide the pattern for the x, in order to find this, we need to do the same for the change in y, which is 6. So we need to take a half a step back from 6, which would be 3, and if we backtrack 3 from 17, we would end up at 14. And that would allow us to backtrack 3 more and be an 11. So sometimes when we're using our patterning skills, we have to keep breaking the pattern down further. And it turns out if we return to our slope, that 6/8 isn't fully reduced, and that those two numbers can both be divided by 2, and we can come up with a reduced fraction for 6/8. And so we can take our 6/8 and we divided it in half, we went half steps back, and see that an equivalent fraction is 3/4. And that's what we ended up having to use to find our starting value. We had to take a half a step back instead of a full step in our pattern. And so when x is 0, y is 14, so 14 is going to be our y value. And we can write an equation now for our table. So go ahead and right here, see if you can write the equation, and let's go ahead and see if we agree. Resume the video when you're ready to compare. So the equation that we come up with using our slope-intercept form is y equals 3/4 x plus 14. And we see that our pattern originally started out as 6/8, a change in y of 6 and a change in x of 8, but then if we break it apart even further, which we needed to do to find our y-intercept, we could divide that in half and find an equivalent pattern where the change in y is 3, which is half of that 6, and the change in x is 4, which is half of the 8. And always when we're writing an equation, we use the most simplified form of slope, which is 3/4. So our equation is y equals 3/4 x plus 14. Let's go ahead and try one more. So here's our example 2. Again, we're being asked to find the missing values and determine what the rule is. So here's the table that they're giving us, and once again we see it's a disorganized table. So using our example from above, I want you to see if you can go ahead and try and figure out the pattern by reorganizing the data and coming up with the rate of change, and realizing that you might have to do some work where you take half steps back or you subdivide the pattern to fill in missing gaps to be able to completely figure out the slope or the rate of change and the starting value to complete the pattern and write an equation that would fit it. And then we're going to compare our work in class. So in order to get full credit for these notes, this problem needs to be completed, or at least started, and we will compare and discuss this in class. So take a moment to work on this problem, make sure your notes are fully complete, and I look forward to looking at this function with you